Okay, all right. So there was some problem in my internet connection. So I think eh, now everything is okay. So can you hear me? Syam Ajmer.
Yes, sir. Good evening.
Yeah, good evening to
You are
everyone.
audible. Yeah. You are audible, sir.
Okay. So a very good evening to all. I am Sahil Group. So here we are. I am going to take the live tutorial session number 3 for the course Operation and Planning of Power Distribution System. So in the last session, we have solved problems based on the load modeling, and today in this session we are continue to solve the problems based on load modeling. And basically in the load modeling, we will more focused on this demand side management. So in the last section, we have done problems based on the some factors that characterize our loads, distribution side loads. So in today's course, in today's session, we will see this demand side management, and then we will solve some problems based on the uh, overview of power distribution networks, and we will see how the busbar arrangements happen in the power distribution networks. So let us begin the session. So first, coming to this, what is demand side management? So if you see, the demand side management includes all measures, programs, equipment, and activities that are tied toward improving efficiency and cost effectiveness of energy usage on the customer side of the meter. And this can be achieved by shaping the load characteristics. And one important point here that in demand side management does not include outage or interruptions. So without doing outage or interruptions, we have to improve the efficiency and cost effectiveness of energy usage on the customer side of the meter. So this demand side management can be categorized into two, uh, two types. The first category is energy saving or conservation programs. In this one, these programs are activities designed to encourage the consumers to replace their less energy efficient equipment while less electricity consuming devices producing the same service, and to change consumer behavior to reduce energy usage. And the second category comes these load management programs. And these programs are designed by utilities to reduce demand peak periods to make more economic use of existing resources to demand displacement over time. So the first one is is like encouragement for where these utility companies used to increase the consumers, how they can replace the less energy efficient equipment by less electricity consuming devices. And the second one that are designed by utilities to reduce the demand peak periods. So now what are the means by which this demand side management happens? So there are 5 types. The first one is peak saving or peak living. So in this, we can see that we are reducing the peak demand. If you reduce the peak demand, means peak, then this total energy consumption also reduce. Here, an example for peak saving or peak living, that efficient control of air conditioners and water heaters. So the peak demand will reduces and total energy consumption also reduces. Let me use the another color pen. and total energy consumption reduces. So this is the load curve of a certain area, and what you are doing that you are clipping the peak demand, means you are reducing the peak demand. So it means that how you uh, how it affects peak demand total energy consumption. So peak demand also reduces, and the whole the area under the load curve with the total energy consumption. So now after clipping the peak demand, this total energy consumption also reduces. The area under this curve also reduces. Therefore, this peak demand and total energy consumption both reduces. So example for this peak saving or peak living is that efficient control of air conditioner water heaters. And now coming to this second means for the demands and measurement, that is value filling. Means how you can increase the off peak demand. Means like here this demand is very low during I suppose this is morning hour and this is late night hours. So this demand is very low. So in the it is a type of value occurring in this load curve. So how you can increase this offload means off peak hours load demand. So these are off peak hours, and this one is center one is the peak hour time, peak demand hour time. So how you can increase the demand during off peak hours? So the one good example that electric vehicle charging. So irrespective of doing in the charging of EV at the during peak hours, you do the EV charging at off peak hours. So you can increase the demand during this value filling during this off peak hours. So here, if you see this, how it affects the peak demand total energy consumption. So if you see this load curve, then peak demand remains same. And total energy consumption will increase. So this curve will move up during this off peak demand. And examples for the value filling is electrical charging. Now coming to the third mean, this is load shifting. The third one is the load shifting. So what you are doing that you are shifting the demand during peak hours to off peak hours. So means whatever the demand you are shifting that happening at the peak hours, you are shifting to off peak hours. So how you can do this load shifting by means of deferrable loads. And deferrable loads means that the loads that allow time shift and interruption. So like washing machine, dishwasher, EV charging. So you can do at any time. Means like it is not compulsory type of loads. Means that happen at always at some instant time. You can do at any instant of time. Either means like you can if you are doing it at evening time or daytime, you can also do it at morning time of late night hours. So you can means that the loads that allow time shift and interruption, and the examples are like washing machine, dishwasher, EV charging. So here I am asking one question that can you say one example for non-deferrable loads? It's like these are deferrable loads that you can allow time shift and interruption. Means it is not a compulsory type of loads. It is not emergency type of loads that it always needs electricity power supply. So anyone can give one example of non-deferrable types of load that you cannot interrupt those type of loads. Yes, Syam, Ajmer, Shiv.
We can shift the load of just means just ironing of clothes uh, from peak hours to in the morning or non-peak hours, and also washing machines.
Yeah, that is okay. I'm saying this non-deferrable type of load. So this is deferrable loads. And non-deferrable loads that does not allow time shift interruption. So I'm asking example of non-deferrable.
यू जो सी
Can
एफ एल बल्लभ सर
Yes.
सी एफ एल बल्लभ जो है सर
Yeah, lighting loads is also non-deferrable loads because it
you
is
are asking
compulsory
is
type of.
efficient loading?
No, no, non-deferrable loads. So these are deferrable loads. Means these loads you can uh, you can do the shifting of time of for the time of use and interruption also. I'm asking the loads that do not allow time shift and interruption. So lightning loads is also one good example, and some other loads you can also think.
Summers, fan and coolers, AC
No,
that are
no,
not.
lighting loads is not deferable, but coolers and this AC are not compulsory type of loads. One good example you can think of like that. It's what it is called. This hospital types means emergency type of loads. This in hospital we have medical uses, so you cannot interrupt the loads that
That
is
means
providing to the hospitals.
that means which loads are required all day supply.
Yeah, means that do not allow time shift interruption. So like if you said this AC and cooler and fan, so you cannot also you can live without these things also. There is not compulsory type of loads. Okay,
Okay,
understood or not?
understood.
Yeah, so the loads that are used in medical purposes that are non-deferrable loads. And deferrable loads are just I said washing machine, dishwasher, and EV charging. And then deferrable like medical purposes, lighting loads you can also say. Means lightning in some area it is a compulsory type of thing. So now if you see for load shifting, what are these impacts on peak demand and load energy consumption? So peak demand, as you can see that you are shifting the load from peak hours to off peak hours. So this peak demand will reduces. And total energy consumption will remain same because whatever the loads that you are using at peak hours, you are now using it at off peak hours. So the total energy consumption will remain same. Now the third load factor. What is the impact on load factor? So load factor, you are since this peak demand reduces, this peak demand reduces, so load factor will increase. And increased load factor is always desirable to utilities. So it is desirable one. So by doing the load shifting, you are increasing the load factor. Now the fourth one is a strategic conservation. And the example for a strategic conservation is the efficient lighting and air conditioning. So by using the efficient use of loads like lightning loads, earlier we are using this incandescent bulb, then the CFL comes. And nowadays LED bulb, we are all using the LED bulbs. So efficient lighting can provide this strategic conservation. Means you are shifting the whole load curve downwards. So a strategic conservation means that you are shifting the whole load curve downwards. Means you are doing the conservation of energy by using the efficient use of lighting and air conditioning. These are examples for a strategic conservation. Now, what are the impacts of this strategic conservation on peak demand and total energy consumption? So you can see from the curve, both the peak demand and peak demand and total energy consumption will reduce. And now the last one is that a strategic load growth means you are increasing the load. So how you can use the efficient planning of power distribution. So you can also tell that you are expanding the power distribution network. So by this strategic load growth, you are shifting the whole load curve upwards. And by this load building a strategy, what are the impacts on this peak demand total energy consumption? Both will increase. So this peak demand also increases and total energy consumption will also increase. So we have seen 5 means of demand side management. The first one is peak saving or peak clipping. In that we are clipping up the peak demand during from the peak hours. In that means in that strategy, this peak demand and total energy consumption both will reduce. And the second one is value filling. In that we are increasing the demand during off peak hours. So by using this total energy consumption will increase while this peak demand remains same. Now third one is load shifting. In load shifting, we are shifting the load from peak hours to off peak hours. So this peak demand will reduce and total energy consumption will remain same. And by doing the load shifting, our load factor will increase. So this is desirable for our utilities. And fourth is strategic conservation. In that we are using the efficient use of loads, and then this will shift the whole load curve downwards. And fifth one is that a strategic load growth or load building that shifts the whole load curve upwards, and by this you are increasing both peak demand total energy consumption. So conservation and load growth both are opposite to each other. Now coming to the next topic. So this is energy rate structure or tariff rate structure. So what is the thumb rule for devising energy pricing? Thumb rule that total revenue that a utility may collect through the sales of its services should be equal to the company's total cost of the service. So whatever this company has invested and whatever the charge, whatever total cost of cost of the electricity that they are providing, it should collected through the sales of its services by sales of its electricity. What are what are the different tariff structures that imposed by the utility companies? So broadly they are classified into 5 types. There are many other types also, but in this course we are going to see these 5 types that are well known and widely used. So the first one is flat demand rate structure. So in flat demand rate structure, a constant price is charged for fixed for the uh, for a unit of energy. Means as the unit of energy consumption increases, this price will also increase in a linear way. So it is fixed for a unit of energy, and based on the energy consumption, this electricity will be come based on the linear basis. And then second one is the block meter data structure. In block meter data structure, as you increases the energy consumption, the price will reduce it. So we will see one problem based on this block meter data structure where we will understood in clear way how this function. So like suppose if you are using you are using 5 kilowatt hour. So till 5 kilowatt hour there is rupees 1 per unit, and if you go beyond than that, then this price will increase, like 5 to 10 kilowatt hour, rupees 2 per unit. And if you go more than 10 kilowatt hour, then this price will again increase. So in that way it works. And third one comes in the demand rate structure. So in demand rate structure, separate charges for demand and energy. So they will having different charge for power and energy. Like there are two charges for kilowatt and kilowatt hour. So kilowatt means power and kilowatt hour means energy. And fourth one is season data structure. So in that in this tariff structure, we are higher prices per kilowatt hour during the season when system peak demand occurs. So we have different prices based on the season when system peak demand occurs. Generally we have higher prices when the system peak demand occurs in that season. So like suppose in summer usually our load demand increases. So in summer we impose higher prices per kilowatt hour, or in winter we have low load demand. So in winter we can say that lower prices per kilowatt hour in winter season. And fifth one is time of day or peak load pricing structure. So it is just similar to season data structure. Difference is only that it is season data structure is based on the seasons when peak demand happens. Higher prices happens during the season when peak demand occurs. And in this time of day structure, we are higher prices during peak period of the day. So this season data structure based on the season, while this time of day structure it is based on the day. So in time of day, we are having higher prices during peak period of the day and lower prices during off peak period of the day. So this is what we have covered till this point. All comes under load modeling. Now let us come to the second module. The second module, that is power distribution network, a brief overview. So in that, if you see the structure of primary distribution networks that are mostly of radial topology, that means this unidirectional power flow happens. And radial topology is preferred for its simplicity in construction, cost effectiveness, and protection arrangement. Now, in the structure of power distribution network that we are going to see in today's session, just in upcoming slides. So, like here, we will see the circuit breakers or isolator. The major difference between circuit breaker and isolators are circuit breakers operates at on-load condition. That means the function of circuit breaker is that it trips and isolates the fault areas, while isolator operates at no load condition, and the function of isolator is from the circuit breaker maintenance. We will also see some problems on circuit breaker and isolators and its function. Now the another term comes with the sectionalizing switches and tie line switches. So here in the right hand side we can see this figure, this radial type primary feeder tie line and sectionalizing switches. So this one is the distribution substation LV bus, and here we are having the circuit breakers. So these are circuit breakers. And this is LV bus. And from this LV bus, we are these three load areas are these three feeders are going outwards. So top one is feeder one load area, and this middle one is this feeder 2 load area, and the bottom one is the feeder 3 load area. So 3 feeders are coming out from this LV bus. And if you see here, these are the primary feeders. And then these primary feeders are connected to the distribution transformer through the fuses. And now here we have to understand this, the working of sectionalizing switches and tie line switches. So sectionalizing switches are present over these lateral points for this connection of different laterals or feeders. And tie line switch are present over here. So these tie line switches are normally open, and it is present where we are having connection of different feeder areas. So these tie line switches are normally open, while the sectionalizing switches are always closed. And these sectionalizing switches used in the fault conditions. Suppose this fault happens in this area. Suppose fault happens in this area. So what happens that these sectionalizing switches are normally closed. So this will open to remove this faulty area. So it is open. This sectionalizing switch is open during fault condition. Therefore, it improves the reliability. It isolates this area and while providing the power supply to other parts. And you can see like this. Suppose this fault happens here. Fault happens here. Then this sectionalizing switch will open to remove this area, and it will other part will remain energized. So this will remove this area. So what is the working of synchronizing switch? Synchronizing switch is used in the fault condition, and it will open during the fault condition, and thus in that way we can say that synchronizing switch improves the reliability. Now coming to this tie line switches. So tie line switches are normally open. So these different feeder area are not connected to each other. So this all of the primary feeders going to this area. That means this depending upon this primary feeder, we have named this load area. So this different load area are connected through this tie lines, which you can say, but we know that these tie lines which are normally open, and we use this tie lines in the emergency condition and maintenance condition. Suppose this uh, suppose this feeder two is a feeder two load area having some maintenance condition is going on. Some there is some problem in this feeder two. So what you can do is that by closing this tie line switch, you can take the power from the feeder one by closing this tie switch. So in that way, you can say that we can use this tie line switch in the emergency condition or maintenance condition. So it is closed during maintenance condition and using the service restoration. So this tie line switches is used to take the power from the other feeder areas. So I hope you understood. Any problem till this point? Any doubt? Yeah, much merci,
No,
Deepak.
sir, please carry on.
Okay. So you uh, you may means like these are very important sectionalizing switches and tie line switches, and these play a major role in this distribution system structure. You have to just remember all these things: sectionalizing switch and tie line switches. So tie line switches, here we have seen that it is used to connect the different feeder area, and it is normally open. And these are used in the emergency condition or maintenance condition, and these are closed during when we want to take power from the other feeders. And there is some problem in your means like primary feeder. Suppose this feeder 2 load area that is taking power from the feeder 2, primary feeder 2, and there is some maintenance or happening in this area, so you can take power from this feeder 1 area or feeder 3 area. And sectionalizing switches that is used in the fault condition, and it is of normally closed type. So these are sectionalizing switch and these are tie line switches. This
Hello.
yes,
Yes, sir. Means tie line switches are those switches which are operated at the time of maintenance, or
which are
we have to
operated.
at the time of maintenance. Means
Yeah,
if any feeder is faulty, then if I have we have to service that feeders, we operated tie line switches. Then we have to work on
yeah.
that part of the feeder.
Suppose they fault in this feeder two area, feeder two load area. Then how you can supply the power to these loads and to this feeder two by using these tie line switches, right? Suppose you are not taking power to this. Suppose this fault type there is some problem, and you are maintaining the circuit breaker, right? So so in maintenance of circuit breaker for this feeder two, what happens? You cannot take power from this feeder two. Then you have to take power from the other feeder. So you can use these tie line switches. You can say this during maintenance of circuit breaker for respective feeders. You cannot take power from that feeder, and in that case, you can take power from the other feeders by closing these tie line switches.
Then we have to close the sectionalizers which are open at the time. If we take power from other feeder, we have to sectionalize the sectionalized switches are normally open then.
The conniving switches are normally closed type, and
Closed type,
the
if the section is faulty, then we have to open those switches, and we have to
yeah,
take power from other feeders by tie line switches.
no, just understood. If there is fault, then we use the sectionizing switch to remove that feeder, to remove that section. So sectionizing switch means like we are removing the section when the fault happen in some section or some part of the area. While this tie line switches we are using to take power from the other feeders when some maintenance is going on. Right. So it is closed during maintenance condition, and you cannot if suppose this feeder is not able to provide, is not providing the power for because maintenance is going on. So in that case, it is saying that it is used in service restoration, means like you can take the power from the other feeder area by closing the tie line switch. So just don't uh, misunderstood like this. For fault condition, we are using sectionizing switches. Why for tie line switches? When we are using tie line switches, like during maintenance condition or emergency condition. Emergency condition means that your feeder is not able to provide power. Means how you will take the power from the how you will take the power? Then you have to depend on the other feeders. That it is telling that emergency condition means that you have to take the power, but your feeder is not able to. Your feeder is going on maintenance, so you can take the power from the other feeders. Okay.
Okay, sir. Okay. Please carry on.
So next is, so this one is the a typical structure for primary feeders. So this one is radial type primary feeder, and a typical distribution feeder consists of main feeder, this central line, and this we call is primary main feeder, and is connect that connects through these several laterals. So from it, there are several laterals coming out, and in laterals, if we again divided, then we call it as sublaterals. So a typical distribution feeder consists of main feeder, and that from that main feeder, we are having several laterals. From laterals coming out, you can see these are the nomenclature that we use in this primary distribution system side. And from laterals, we are again having sublaterals. So from this figure, you can clearly understand what main feeder, main feeder, and what we call laterals or what we call sublaterals. So here we can see that this LV bus, distribution substation LV bus, and from there, this is circuit breaker. And from this primary main feeder, this is coming out these laterals. So these are laterals, and this is fuse. So this notation is for fuse, and then we are having this distribution transformer, and these are transformer fuses already written, no need to write. And from laterals, we are having this coming out sublaterals, and if the fuse is using in these laterals, then we call it a lateral fuses. Now coming to the next part, where we will going to see different types of bus bar arrangement, or you can say that switch gear arrangement. So the typical structure that we are going to see uh, in this session is that single bus scheme, then single bus with a sectionalizer scheme, single bus with a sectionalizer and two power transformer scheme, then main and transformer bus scheme, double bus bar scheme, ring bus scheme, breaker and half scheme. So in today's session, there is no numerical type problems. That's why we have to understand the terms and terminology. What are the things means? All problems are theoretical type. Just focus on theory. There are no numerical questions in assignment 3. So the first one is that single bus bar arrangement with one main power transformer. So this first busbar arrangement is that single busbar arrangement with one main power transformer. So this is one of the most conventional type of structure, conventional type of arrangement. So from the top, this incoming line, that is some sub transmission line are coming out, and before that we are having this power transformer, and here in the top we are having sub transmission line. So here in this second case where we have a single bus arrangement with bus sectionalizer and two power transformers. So top one, these lines you can say that sub transmission lines. And then these are power transformers. And this is isolator. We know that at the both end of circuit breaker we are having isolator. So isolators are used when we require the maintenance of circuit breaker. This is first one, that here we are having single bus bar arrangement. This one bus is present and that are providing, that are connected to different feeders. So these lines means these are different feeders. These are different primary feeders or main feeders. So if you see, and these are feeder circuit breaker. You can say that these are. So in the first arrangement, you can say that this whole substation out of service while fault in MB bus bar. So if there is fault in MB bus bar, this whole station will go out or go out of service. And also when this power transformers goes out of service or circuit breaker out of service, then this whole substation will go out in service. Means there is no power supply from the substation. While in the second case, we are having this power transformer, two power transformers. So if there is fault in one power transformer, then the other power transformer can provide the power to the feeders. So this one is the bus synchronizer. This middle one, this is bus synchronizer. So in this case, we are having two power transformers, and if so here we can see that we are doing this parallelic power transformer that needs additional control logic. And this also, if you see the advantage, this increase the operational flexibility, and fault in bus bar would be limited to one section only. If there is fault in this bus bar, then from the other power transformer, we can take the power. So this is the advantage of single bus element with bus sectionalizer and two power transformers. So in first case, we have seen that this whole substation out of service while fault in MB bus bar. While in the second case, if there is fault in MB bus bar, then other power transformer is operating and provides the service to the can provide the service. Now third case is that single bus arrangement with third case is the single bus arrangement with transfer bus. So this you can see that top one is the main bus, and below one is transfer bus. And this main bus is always energized, means always connected, while this transfer bus, we can see this bus circuit breaker, this bus tie breaker. And bus tie breaker is of, we know that it is of normally open type. So this is normally open type, and since this is normally open type, that means this transfer bus is not energized, and it is energized through this tie breaker by the main bus during the circuit breaker maintenance. And suppose this circuit breakers is going under maintenance, then what happens that by energizing this transfer bus, by closing this tie breaker, you can provide the power to the feeders through this transfer bus. So this is the use of transfer bus. When we are having this circuit breaker maintenance, we can energize the transfer bus by closing this tie breaker, and we can provide the service to the feeders. And then the next is double bus bar arrangement. Here both buses are always energized. So in this opposite of this single bus bar transfer scheme, in double bus bar arrangement, both buses are always energized and connected by the tie breaker. And it provides operational flexibility, that is possibility to move the load between buses. So from either bus, you can take the power, you can provide the power to the feeders, either from the bus 1 or bus 2. Now, the next case is double breaker arrangement. In that case, one feeder is connected by two circuit breakers with respective buses. And then we are having this ring bus scheme. And here each circuit can be fed by two breakers. And if a fault occurs during a breaker maintenance period, the ring can separate in two sections. And the last structure is that a breaker and half scheme. And this is one of the very popular and used in many substations. So this switchgear arrangement is very popular and used in many substations. And here, if you see this, then we are having three circuit breakers for two feeders. So like this circuit breaker, this one, and this one. So there are three circuit breakers for two feeders. So that means you can say that for one feeder we require, and there are 1.5 circuit breakers. That's why its name is breaker and half a scheme, because for a one feeder we are using 1.5 circuit breakers. So these are all for bus bar arrangement. Now coming to the next section. So there are some problems on this typical outdoor and indoor substation. So you can refer to the last lecture, and here I am just noted down the important points. What are the difference between outdoor substation and indoor substation? So for the outdoor substation, the space requirement is more, while the indoor substation, the space requirement is less. And the cost for outdoor substation is cheaper, while for indoor substation it is expensive. And the maintenance for outdoor substation is more, while it is less for indoor substation, because maintenance is more for outdoor substation because it is more prone to fault. So in the outdoor substation, more faults are happening due to some nature reason or some other reasons. That's why maintenance cost is more for outdoor substation, while indoor substation maintenance cost is less. Fault location is easier in outdoor substation, while it is difficult in indoor substation because all things are visible in outdoor substation clearly. That's why fault location we can depict the fault easier in outdoor substation. While in indoor substation, it is more difficult. Reliability in outdoor substation is because it is more prone to hits, while reliability is higher in indoor substation. Now, what this timely fit? How the primary fits are designed based on the ability. This primary features located in low density means in rural area are restricted to the length and loading by permissible voltage drop rather than thermal resistance. In low load density areas, that means in rural areas, we see voltage drop, designing the primary feeder. Whereas these primary feeders in high load density areas, for example, industrial and commercial areas, may be restricted by the thermal limitation. So the length of primary feeders in low load or rural areas are restricted by the voltage drop, while in high load density areas or industrial or commercial areas, the length is restricted by thermal limitation and capacity limit. Thermal limitation or capacity limit both are the same thing. So these are the summary for this assignment 3. Now we are going to solve some problems based on the whatever we have revised, whatever we have seen in these slides. So coming to the first problem. The first problem is that single bus bar arrangement in substation is used for voltages 1 to 11 to 33 kV, V66 to 110 kV, D is 132 to 2022 kV, and then D is 220 to 765 kV. You can write on chat box. In today's session,
We
there will be
can't, we
no.
can't see your slide, sir. I think it's getting late to come on our.
Let me share again. So I will just stopping the sharing. Let me share it again. Now it is visible.
No, it's not visible to us.
Still not visible.
Still not visible to me.
Other one, other other people can verify that it is visible or not.
In Kahragan not visible.
Ajmer, you are also not visible.
Not visible, sir.
Okay, Syam, can you see the screen?
Yeah, now it's visible to us.
Okay.
Yeah, now. Okay, okay. It's now
There,
visible.
there is some problem in my college today. Live
Okay.
connection in
Maybe
internet
some
connection.
network issue.
So
No.
you can type across the chat box. They no need to open your notebook to do. They no need to open the pen and do the
Okay, now it's
numericals.
visible.
Just a verbal type question today you have. So the first question that single bus per arrangement in substation is used for voltages. And the options are 11 to 33 kV, 66, 110 kV, 132, 220 kV, 222, 765 kV. Yes, anyone can write answer in chat box. Yes, Syam, good. So the first one is correct. We know that the what is the voltage level for our primary distribution system. It is of 2.2 kV to 3.34.5 kV. The range, if you see the range for primary distribution system, then only one option is coming, 1133 kV, 11 to 33 kV. So the first option is correct. Other ones are for like sub transmission system, transmission system. So A option is correct. Moving to the next problem. Which of the following factor must be considered at the time of primary feeder routing? And the options are type of load, feeder type, substation type, load density. Anyone can? If anyone knows the answer, then you can tell your answer. Yes, I got one answer D. Yes, correct, Syam. You are correct. Load density, the correct answer. So the factor be considered at the time of primary feeder routing is load density, not type of loads, not the feeder type, not the substation type. So I am writing the factors or decision that considered for primary feeder routing. Decision on primary feeder that are considered. First one is load density, and then physical barriers, and voltage drops, then future load growth, then number of feeders, and then total cost. So these are the cost, these are the factors that we consider at the time of primary feeder routing. So if we see here, this load density is matching with the option. So D option is the correct. Now coming to the next problem. So here problem it is asking that which of the following is the primary goal of demand side management, and the options are to increase the transmission capacity, to reduce the distribution feeder loss, to manage and modify customer electricity usage, to increase the grid reliability. You can type in chat box. Only Syam is giving the response. Other one, please you also try. I think today's assignment is one of the easiest assignment that we are solving. So Syam is saying answer option C. Deepak also saying option C. Yes, both of you are correct. So to the primary goal of demand side measurement, first is to increase the transmission capacity. No, there is nothing relation with the transmission capacity. To reduce the distribution feeder loss, we are not reducing the distribution feeder loss. To manage and modify customer electricity usage, yes, we are managing or modify the customer electricity usage. That comes under the goal of demand side management. So C option is correct. And the last is to increase the grid reliability. Is also incorrect. So next problem is, in a distribution feeder, normally closed type switch is installed for. Options are establishing a closed network, creating alternative service path in case of a fault, isolating the faulty section from the healthy part of the feeder during a fault, minimizing the power losses. So isolating the faulty section from the healthy part of the feeder during a fault. This one is correct. Who has given the correct answer? Deepak said C, Syam said A. Syam, your answer is wrong. Deepak, you are correct. C option is correct. Isolating the faulty section from the healthy part of feeder during a fault. So we have seen that which one is the normal closed type switch? Sectionalizing switches are of normally closed type. And we have seen this normally closed type. We use this to remove the faulty section from the healthy part of the feeder. So we have seen in the initial slides. So from there you can refer. Sectionalized switch are of normally closed type, and they are used in the fault condition. used in fault condition, and as the fault happen, it will open. So that's in that way it will isolate. So it is opened during fault condition. So C is correct. Deepak, your answer is correct. The next problem is that what is the primary decisive factor for determining the permissible length and loading of an urban distribution feeder? Options are establishing closed network, creating alternative service path in case of a fault. Sorry, options are incorrect. There is a mistake. So let me type the options. Sorry for this mistake. I think previous option just written here. The first option is frequency limit, and second option is voltage drop limit. Third option is ampacity limit, and the option is phase angle limit. So you have to tell for the urban distribution feeder what is the primary decisive factor for determining the length and loading. Options are frequency limit, voltage drop limit, ampacity limit, phase angle limit.
Only the two option is showing, and I think B is the right answer.
Other
Page
options are
number
not
shown.
showing.
Yeah, only two options: frequency limit and voltage drop limit.
I think some lagging problem happening. Still it is showing only two options. Hello.
Now it is visual. All four options.
I think class is not. So now say you can tell your answer. So Deepak said B. Yam said also B. I just said earlier for urban distribution feeder, what factors the primary decisive factor we have to taken care of. So, both the B answer is wrong. So for the urban distribution feeder, we considered the ampacity limit, not the voltage drop limit. So this I'm just copying it and I am pasting over here. So for the high load density area, like this urban distribution feeder will come under high load density area. So this comes under high load density area. And high load density area means you have to consider the thermal limitation or ampacity limit. While the low load density area, we are considering the voltage drop. And low load density area means rural areas. While high load density area means industrial commercial load, or you can also say this urban distribution feeder, where this distribution, where the load density is very high, right? So can anyone tell what is the reason behind that? In high load density area, we consider the ampacity limit, while in low load density area, we consider the voltage drop. Syam or Shiv, Deepak, Ajmer, anyone can try.
In urban area, the load is very heavy, and the
Yes,
length of the feeder is not much longer. So we consider that if the line length is more, or feeder length is more, then we have to consider the voltage drop.
yes, correct. Correct, Syam. You are very good. Means like in high load density areas, we are having thermal limitation because density is high. So we have to consider its capacity, how much power it can deliver. While in the load density areas, means loads are scattered and are having at different distances, much different at much different distances. So there we consider the voltage drops rather than its limit. What is power carrying capacity or thermal limitation or ampacity limit. So low load density areas means your loads are in a scattered way and they are in much distance from each other. So there we are considering low voltage drop in low load density area, while in high load density area we are considering the ampacity limit. So coming to the next problem. The next problem that concept of negawatt emphasizes, and the options are the need for constructing more power plants. B option is the importance of increasing electricity demand. C option is the significance of investing in renewable energy sources. D option is the value of reducing electricity consumption. So anyone can try and you can type once in the chat box. Okay, I got one response. Deepak A. Just read the question carefully, and this is covered in the class lecture. So I will just write some important points about the negawatt, but you first try yourself. I'm just coming in 1 minute. Okay, got response. Syam saying D and Deepak is saying A. Syam, your answer is correct. D is the correct answer. Megawatt means the value of reducing electricity consumption. This is the correct answer. The negawatt means a negative watt. The negawatt of electricity saved through demand side management is as good as a watt of generation capacity. For instance, if a utility manages to reduce electricity demand, it can postpone the construction of can postpone the construction of expensive new power plants. New power plants are increased reliability or increased reliability. And the last point that this needs new government regulations or directives to ensure that utilities will undertake demand side management programs. So this is all about the megawatt concept. So let us move to the next problem. So the next problem is about the tariff structure. So in this problem, it is asking that in electricity billing, which tariff structure aims to incentivize consumers to adjust their usage patterns towards periods of lower demand. There means which tariff structure incentivize consumers to adjust their usage patterns towards periods of lower demand. And the options are flat demand rate, block meter rate, peak load pricing, and D is demand rate. I got one response. Syam is saying C. To respond, Deepak Yao saying C. Yes, correct. C option is correct. Peak load pricing. Peak load pricing is a. So I am writing all the words from the notes of from the lectures of NPTEL. Peak load pricing is a pricing strategy where prices are raised during periods of high demand. The primary goal of peak load pricing is to control demand during peak times and achieve optimal allocation of resources. So the primary goal of the peak load pricing is to control demand during peak times. So, and that means we are incentivizing consumers to adjust their usage patterns towards period of lower demand. Now coming to the next problem. So the next problem is that what is the difference between primary and secondary distribution network? And the options are topology, voltage level, direction of power flow, radial operation. Please write on answer in the chat box. So what do you think? What is the key difference between primary and distribution topology, voltage level, direction of power flow, or radial operation? Okay. So Deepak is saying V, Syam is saying A. So B is the correct answer. Deepak, you are correct. So for voltage level is the primary is the key difference between primary distribution network. So if you see the voltage level for primary, it is like 11 kV, 33 kV. Or maybe up 2.2 kV. Mainly it is 11 kV and 33 kV. While for secondary distribution network, we know that voltage level is of at utility level voltage. So it is of 400 volt line to line voltage. And if you see the other things, topology is radial, or it is the same, it is not with topology. And if you see the direction of power flow, then it is of unidirectional because it is of radial topology. So both are of unidirectional type. And We know that both are of in radial operation. So the correct answer is voltage level. Coming to the next problem. Why is circuit breaker positioned between two isolators? And the options are to safeguard the isolator from faults, for conducting routine maintenance on the circuit breakers, to shield the circuit breaker from the lightning surges, and D option is for the purpose of reclosing the breaker after a fault. Yes. Syam is saying C, Deepak is saying B. Deepak, you are correct for conducting routine maintenance on the circuit breakers. So B option is correct. So we know that in this problem they are asking about isolator, not not the function of circuit breaker. So we know that isolator operates at no load condition. And the function of isolator is to function of isolator to perform the circuit breaker maintenance. To perform the circuit breaker maintenance. So B option is correct. Now coming to the last problem. Problem for the last assignment question. So it is asking about which of the following can be considered as one of the base of a strategic conservation. So it is asking about a strategic conservation. And the options are efficient refrigeration, air conditioning, electric vehicle charging, or load shifting. Yes. And in this problem, one thing I want to mention, the multiple select question. More than one options are correct. Deepak saying D. No, D not correct. A strategic conservation means efficient refrigeration and air conditioning. A and B are correct. So I think we have see the you go through the initial slides where I have covered these things. So see here, a strategic conservation means example for a strategic conservation means efficient lighting or air conditioning. So if light, lighting and air conditioning both should be efficient, then you can conserve the electricity energy. So A and B are correct options. So till this, we have covered the last year assignment problems, and after that, I have already solved all the problems for the subsequent years, and you can go through it. I will upload the PDF. I will upload the slides on this on the portal where you can access these slides and you can revise all the problems for the subsequent years. Now, I think many of you have problem regarding this. What you say? You are not able to open the assignment 3, right? Yam Deepak. Syam, are you able to open the assignment 3? Deepak?
Can you ask again, sir? Sorry.
Yes, I am asking that whether you are open to able to open the assignment 3 of this current year, current course. Are you able to get the question? What I'm asking?
Assignment or sir, online assignment or what?
Yes, online assignment on SWAYAM portal.
No, no, no. We are not getting that.
I think there may be some problem. Tomorrow they will rectify, hopefully.
Okay, sir. Okay.
It is not showing here, right? For week 4 it is showing, but for week 3 it is not showing. I think tomorrow they will rectify this problem and hopefully they will communicate you through uh, mail. In discussion forum they will reply the, if you join the discussion forum you will get the mail also, otherwise you may not get the mail, because once you opted the discussion forum then only you will get the mail. Now I will just quickly revise all the problems of the subsequent years, like for 2023. The first problem is that which of the following can be considered as one of the ways for load valley filling, and how you can fill the load valley means how you can increase the demand during off-peak hours. So one of the way is that you can do your electric vehicle charging during off-peak hours. So the correct answer is C. The next problem is that which of the following statements are true regarding indoor and outdoor substations? When I am discussing these problems of the previous year that I have already solved, if you feel any doubt or any concern, you can please ask. So here, which of the following terminology is are true regarding the indoor and outdoor substation? It is of multiple select question type, and the options are given here. So the first option is given that outdoor station has a high reliability. So it is false. Outdoor substation is having low reliability, and because it is more prone to faults. B option is outdoor substation needs higher maintenance compared to indoor substation. Yes, it is correct. It requires more maintenance because it is open in area and it is more more fault can happen. C option is outdoor services suitable for cities with higher population density. It is incorrect. B prefer in higher popular densities this indoor substation, and outdoor substation we prefer where we have enough spaces like in rural areas or somewhere there is low density, low population areas. D option is outdoor substation is less expensive than indoor substation. No. Yes, it is correct. Indoor substations are of higher cost or expensive, while while the outdoor substations are of cheaper type. Next problem that circuit breaker and isolator respectively can be operated at. Circuit breaker operates at on-load condition, means it trips and isolates the fault areas. Relays are providing the trip signal, and a circuit breaker isolates these fault areas. And isolator operates at no load condition, means we remove the isolators to perform the circuit breaker maintenance. So this isolator operates at no load condition. We use this isolator to perform the circuit breaker maintenance, while circuit breaker operates at on load condition, and this circuit breaker gets the trip signal from the relays and it isolates the faulty areas. The next problem is that topology of transmission distribution networks are. So we have seen in the previous session, transmission networks are of mesh topology. Mesh topology means various power flow paths are available, while radial topology means you have unidirectional power flow. So topology for transmission is mesh type, while distribution network is of radial type. Mesh topology means what you understand by mesh topology. It means that you have various power flow path, while for radial topology you are having unidirectional power flow path. The next is when fault occurs in distribution feeder, fault isolation and service restoration actions during the fault location can be carried out by. So we know that sectionalizing switches are of normally closed type and it will open during fault when fault happens, while tie line switches be used in the emergency purposes or be used in the maintenance purposes. Therefore, these tie line switches used in the service restoration actions depend on the fault location. So sectionalizing switches used in the fault isolation, while tie line switches be used in the service restoration during the emergency or maintenance purposes. So sixth problem is which of following is considered as a flat demand tariff structure. So flat demand tariff structure is one of the easiest, means the first one what we have seen tariff structure. The first one by the flat demand tariff structure, in that a constant price per kilowatt hour is considered. So C option is correct. And the next problem is that which of following is not a decision factor on the conduction side. So if you see this figure, there we are having different factors affecting conductor size selection. So these includes voltage drops, transformer rating, conductor rating, total cost, power losses, load growth rate, load forecast. So here this substation capacity will not a decision factor for the conductor size. Another one like conductor rating, power losses, voltage drop, we consider a decision factor of conductor size. Therefore, the incorrect option is D, substation capacity. Eighth one is which of following is substation equipment, bus bar, current transformer, battery bank, all of these. So all are the equipment, all are the items present in substation. So all of these are correct answer. And here you can see this equipment present in substation. The options are power transformers. The equipments include power transformers, circuit breakers and isolators, station buses and insulators, current and potential transformers, shunt capacitors, grounding system, lightning arresters and or gaps, protective relays, station batteries. The next problem is that tie line and sliding switch are respectively. Tie line switches are of normally open type, and we have seen that be used in emergency condition or maintenance condition, and it's closed during emergency maintenance condition. While sectionalizing switches are of normally closed type, and it is used in fault condition, it is open during fault condition. And the next is which of the following factors affect the variable losses in distribution network. So we know that this if you see variable losses in the distribution network, load power factor and feeder design will decide the variable losses, because this copper losses are variable losses and this copper losses is dependent on this load power factor and feeder design, because based on the feeder design it decides the length of the feeders, while load power factor will decide the amount of current will flowing through that feeder. And this A option and C option are incorrect. A option is quality of transformer core material. It is not dependent. It is not affecting the variable losses, and substation capacity is also not affecting the variable losses. So now coming to the next section, that we are going to see the problems of assignment for the year 2022. So the first problem is that if you see all the problems are of similar type. If you have solved 1 year problem, then you are able to solve other year problems also. So the first option is that visual planning is an approach of for demand side management. And the options are load forecasting, load estimation, load setting, load shifting. So if you see all the first three options are incorrect, means of demand side management are peak saving, peak clipping, heavily filling, load shifting, strategic conservation, strategic load growth or load building. So from this approaches of demand side management, only one option is correct, load shifting. And these are the figures for all 5 types of approaches for demand side management: peak clipping, value filling, load shifting, load conservation, strategic conservation, and strategic load growth or load building. Coming to the next problem, which of the following devices can be controlled as one of the means of peak saving? So we know that efficient control of air conditioner, water heaters, you can do peak saving, means you can increase the peak load demand. C option is correct. The next problem is that which of following customers can be called prosumers? So earlier, when we don't have these renewable energy sources, uh, uh, but due to the invention of power to convert, due to this power to converters, nowadays this solar photovoltaic we are installing our households. In that way, we can say that we can produce electricity with consuming electricity as well. So we are producing electricity as well as we are consuming electricity from the utilities. You can say that you can produce, sell, and consume electricity. So that is the meaning of prosumers. So pro means producer and sumer means consumer. So it is combined from a producer and consumer. So earlier uh, we don't have the integration of solar photovoltaic or windmill, while we can incorporate some electricity from the solar energy and wind energy in household, and we can feed the power to the grid also. So we can sell the electricity to grid also, and we are even consuming the electricity from the grid when these renewable sources are not enough to supply the load, household load. So it is very simple, and these terms are just came recently few years ago. Prosumer, and prosumer means a customer who can produce, sell, and consume electricity. The problem is that the flowing busbar scheme does not interrupted due to busbar faults, and it is multiple select question. We have seen the different switchgear arrangements where we have seen that single bus scheme, single bus with transfer bus scheme, double bus bar scheme, double breaker spring, one and half bus, one and half breaker scheme also. So in single bus scheme and single bus with transfer scheme, in both cases we have seen that how this bus bar scheme uh, will be interrupted and will not able to provide the power to the feeders due to bus bar faults. While this double bus bar scheme, double breaker schemes, they have the flexibility. Even the bus bar fault happens, they can provide the power to the feeders. So C and D are the correct options. Next, coming to the, and you can refer this lecture 8 for having to study different types of physical arrangement or busbar arrangements. The next question, number 5, a sectionalizing switch is placed in a distribution feeder to remove the reliability, because sectionalizing switches are normally closed type and these are operated during fault condition, and when fault happens it removes the faulty areas while providing the uh, so it removes the faulty areas. In that way we can say that there is uninterruptible power supply to other areas. So it means that we can say that it improves the reliability. So signalizing switches are improving the reliability by removing the faulty areas, and in that way this feeder is providing the uninterrupted power supply to the non-faulty areas. Six number problem is an isolator can be operated at. We have seen that it is operating a no load condition. Seventh problem that in a substation with different bus scheme, it is seen that circuit breaker is kept between two isolators. The isolator is used to perform the circuit breaker maintenance. This distribution of topology is usually readily due to unidirectional power flow, e.g. protection coordination and cost-effective construction. So D option is correct, all of them. Ninth problem is visual flowing will be considered a most important decision factor for choosing the permissible length of rural distribution feeder. So rural distribution feeder means it is of low load density area. So voltage drop will be the DCG factor, while in the high load density area, thermal limitation or capacity limit is the DCG factor. The lateral implies to. So we know that lateral is a branch of distribution factor. So B option is the correct answer. The depiction of fault location is in the blanks in indoor substation, then that of in outdoor substation, then that of indoor substation. So the depiction of fault location is easier in outdoor substation than that of indoor substation, because we can easily visualize all the things in outdoor substation clearly. So that's why depiction of fault location is easier in outdoor substation. Visual fluent tariff structure is considered as a block meter data structure. So in block meter data structure, lower prices for greater usage. So we can see that here. So in block 1, first 50 units, rupees 5 per unit. In block 2, next 30 units will be rupees 4 per unit. And in block 3, next 30 units will be rupees 3 per unit. So as the consumption increases, the price is reducing. So lower prices for greater usage. I think in initial slides I had said something wrong. I have increased the price, but in if you see here, this in block meter data structure, the prices will be reduced on the greater usage. So from the slope you can clearly say how the price is reducing if you increase the unit consumption. Visual flowing is a DCG factor on the conductor size selection. So you can see this figure. This conductor rating is one of the decision factor in conductor size selection. Visual flowing is not a substation equipment. Power transformer, CT and PT, CT and PT में current transformer, potential transformer, CV and isolators. D is battery reservoir. So battery reservoir correct answer. Battery reservoir generally be required in the generation side, not in distribution substation side. So these are all for today's session. Hope you will able to solve this current third assignment for this course. If you have anything to ask, any doubt or any concern, you please ask. Otherwise, we will meet on the next session number 4 on the next Sunday. Ajmer, Deepak, Rahul, anything you want to ask? Otherwise, we can end this today's session. We can close this today's session. Ajmer, Rahul, Deepak. Okay. Thank you all for attending today's session, and we will meet on the next Sunday. Thank you all. Now I'm closing this session.